Yeah, now you start. Read the question.
Variable x and y are related by equation y is equal to p minus qx, where p and q are constant. Values of x and y are measured experimentally. The results contain a symmetric error. Which graph best represents these results?
Okay, listen. To get the proper recording of the notes, it's better to have the printout of the worksheet. Okay, so if possible, with
Yes, sir.
someone you get the worksheet printed, please do it. It's very much important for your
আচ্ছা
entire
স্যার পুরো
notes.
ওয়ার্কশিট প্রিন্ট আউট কত টাকার মতো লাগতে পারে স্যার?
Sorry,
পুরো
full
ওয়ার্কশিটটা প্রিন্ট আউট
worksheet.
দিতে কত টাকার মতো লাগতে
Full worksheet is 21 pages. You see, you know how many 21 pages means if you do both sides, then it comes 10
পারে?
pages, 10, 11 pages it comes.
Yes.
So you understand how much it will take.
Hmm.
320, the 60, 70 like that, 60, 65 taka. If 3 taka per page, if you have someone who can print out with 2 taka, then it is like less, around 50 taka you can do it.
Yes, sir.
So do it, huh?
All right.
What could be the possible answer of it? Can you think of?
Yes.
Hmm, please. Look, we have the equation. Equation is given. So
Yeah.
y equals p minus qx. It is a straight line equation, right? Y equals
Hmm.
mx plus c. So if it is a straight line equation, we can easily skip c and d.
Yes, sir.
Then a and b you compare.
Is this A?
Yes, very good. Why a? Why you are thinking a?
It was just a hunch, sir.
Mm-hmm.
It was just a hunch.
I'm not getting what?
It was a hunch, sir. I just guessed it was A
Oh, you guessed.
because
Look, they are asking you the question which graph best represents this result, and just before that, they told you the results contain a systematic error, right?
yes, sir.
So, if it is with systematic error, then it will not start from the P, right? Uh,
Yes, sir.
because you see, if there is systematic error, then it will start from, we know that it's not starting from zero, right? In
Yes.
systematic error. So we have some values either more or less, right, from the true value. That's
Yeah.
why if you like our graph is starting from y equals 0, right? X equals 0. So if
Yes.
you put the value of x 0 at the beginning, it should be y equals p, right? It should be y
Yes.
equals p. But there is systematic error. That's why it should not be y equals p. It will be something else, either less or more, right? So
Yes.
we can choose now A. Is it clear?
Yes, sir.
So take the record. For 15, you write y equals p minus qx. It is a straight line equation, and here we have systematic error. These two information you write in your copy so that later you can recall.
Yes.
Otherwise, you will forget, right?
Yes, sir.
And
I
then after
already wrote.
taking, yeah, after taking the printout, even when you will go to write, you will forget. Then our next one is 17. 16 we did before. You can also check, huh? In your record copy, you might have this writing about 16. You check later, huh? After the class is over. If there is anything left, then we can discuss in our next class also. Okay.
Yes, sir.
Okay. Now continue. 17, please.
Yes, sir. In this circuit shown, an analog ammeter is to be recalibrated as a thermometer. The graph, the graph shows now the. Is this shows or snows, sir?
Where shows
Also,
shows how there is some part cut at the top.
the graph shows how the resistance R of the transmitter changes with the temperature T. Which diagram could represent the temperature scale on the ammeter?
So they are saying about thermistor, right?
Yes, sir.
Yeah, resistance R of the thermistor. Resistance R of the thermistor changes with temperature T. So you see the graph how thermistor is working. If temperature increases, the resistance decreases, right?
Yes, sir.
And at the beginning, the temperature with small temperature rise, the resistance is decreasing drastically, right?
Yes, sir.
So if your resistance is decreasing in one, in one circuit, then what will happen to current? Current will increase, right?
Yes, sir.
Current will increase drastically. So you write this in front. What I am saying, you write on your copy that in thermistor,
Yes, sir.
resistance decreases with increasing temperature. So another point you write in the graph shown, the resistance decreases drastically for a small change in temperature at the beginning.
In the graph shown,
In the graph shown, the resistance decreases drastically for a little temperature increase at the beginning. Therefore, we can say,
yes,
therefore, we can say current increases sharply current increases sharply at the beginning.
yes,
Now you check the diagrams. A, B, C, D. Which one will be your answer? Check. Ammeter is showing you current, right?
yes, sir.
So with temperature rise, how the current will be changing, you check it there.
This B.
It will be
B.
Bangladesh.
Yes, sir.
Your graph is showing you temperature, right? Temperature and resistance, isn't it?
Yes, sir.
So which one is showing you current increases most?
Sir, B, right, sir? Oh, no, sir. Could be
Could be A, right?
A. Yes, sir.
Yeah, could be A because our increase in temperature, with increase in temperature, small change in temperature, the current is most in A, right? Isn't it?
Yes. Yes, sir.
Okay, so 17 you write A, huh?
Yes.
Then we have next one. Let me check in the worksheet. Yeah, next one is after 17, it is 22. We will go to 22 now. Now we are doing the difficult one, okay?
Right, sir.
Like this one, if you are confused still, like they are saying temperature scale, right? They are saying temperature
Yes, sir.
scale on the emitter. So our temperature scale, you see temperature is increasing here little, right? And emitter reading
Yes,
is
sir.
this needle, right? So this one is for temperature scale. If they are saying current scale, then it could be the answer, okay?
Yes, sir.
Hmm. Then 22. Can you read 22?
Yes, sir. An uncalibrated analog voltmeter P is connected in parallel and another voltmeter Q, which is known to be accurately calibrated for a range of values of potential difference. Readings are taken from 2 meters. The, the diagram shows the calibration graph of update. The graph shows the meter P has a zero error. This meter is now adjusted to remove the zero error. Uh, when the meter is recalibrated, the gradient of calibration graph is found to be uncharged. What is the new scale reading on meter P when it is used to measure PD of 5.0 volt?
So we got here two information. The first information is If you have here zero error, right?
Yes, sir.
So if zero error is removed, you see now the graph is not starting from the origin, right?
Yes, sir.
But if you remove the zero error, then the graph will start from zero, right? From the origin.
Yes, sir.
This is first idea. And second idea is they are saying the gradient of the calibration graph is found to be unchanged. So if the gradient is same, they should be parallel, right? The new line should be parallel, isn't it? The
Yes,
new
sir.
line should be parallel to the previous line if the gradient is same. Is it clear to you?
Yes, sir.
So you write these 2 points. First point, what you wrote?
The gradient is unchanged.
No, the first point I said, if zero error is removed, then the graph will go through
Yes.
the origin.
Yes, sir.
That one you write. This is first point for question 22. So you will draw another straight line from the origin, right? Then if the second point is, as the gradient is same, the new line will be parallel to the previous line.
Yes, sir.
Now I'm drawing the line, you see. Are you seeing the line?
Yes, sir.
You should draw one line after you get the printout. You should draw one line here with ruler which is parallel to the previous line. Okay,
Yes,
now
sir.
uh, they are saying what is the new scale reading on meter P when it is used to measure a potential difference of 5 volts. So our potential difference 5 volt here, that one
Yes.
we will continue from here. A straight line you will draw from here up, go up, go up, go up till here,
Yes, sir.
and you check what is the reading is coming in P. If you draw from here straight line till the P, is it okay?
Yes, sir.
So here you got the value of P. You can check with the reading. We have 10 small squares, right? Between 6 and 8. So each of the small square is giving you 0.2, right?
Yes, sir.
So you count how many small square we reached there. is so far we can understand. If we check from here back, then you see it's coming almost 3 squares, right? Isn't it?
Yes, sir.
So you
Yes.
deduct from there 0.6. Yeah. So it's coming 7.4, right?
Yes, sir.
So your answer is Dhaka, right?
Yes.
Your answer Dhaka is given 7.4. So you got it. How to do it?
Yes, sir.
So
This one was not that tough, sir.
you took the notes right on your copy,
Yes, sir.
and you are taking class. You are having class with your laptop or your mobile.
It's my laptop, sir.
Okay. So you can have a snap from your mobile. From your laptop with your
Yes.
mobile of this diagram. Take a snap.
Yes.
Okay, then you can remember it easily how to do it. Okay, and send it to our group now. Group 6, batch 6 group messenger from your mobile. Is it possible?
Sir, I did not hear anything. I went to get my phone, sir. This time.
Yeah, it's not there. Internet. Hello.
Yes, sir.
You can't send it now.
Yeah, I can send it now.
Yeah, send it in our group, batch 6 group. This diagram, so that it is recorded over there, right? You can easily find it, and it is permanent. Even if it is deleted from your mobile, you can check it from here, right?
Yes, sir.
Anytime, anywhere of the world. So done. Taking snap is done.
Yes, sir. I'm sending it. I can find it. Yeah. I found
Yeah. Yes. Good. Okay. Now we are continuing. Next one. Our next one is. Let us check. Question number 24. Huh? Question number 24. This is a little bit tricky question. Easy question. Concept is easy, but little bit tricky there. Can you read question number 24?
Inequality X varies with temperature as shown. Theta is determined from corresponding values of X by using this graph. X is measured with a percentage uncertainty of 1% of its value at all temperatures. Which statement about the uncertainty in theta is correct?
Yeah, choose your answer.
Sir, I cannot find the answer, sir.
Yeah, now look here, the percentage uncertainty given. Plus minus 1%, right? Isn't it? Hello?
Yes,
Hello.
sir.
The
Hello.
percentage uncertainty given is 1%, right?
Hello, sir. Can you hear me?
Yes.
Oh,
I'm saying the percentage uncertainty given is 1%, right?
yes, sir.
So 1%, if you take it in decimal point, what it will come? 0.01, right?
Uh, yeah. Yes, sir.
So if you think of 0.01, so if you multiply any temperature with 0.01, then it will be very small, right?
Yes.
Like actual uncertainty, any in any thermometer we have actual uncertainty. Normally it is 1 degree Celsius, right?
Yes, sir.
1 degree or 0.5 degree Celsius or maximum 2 degree Celsius is some of the thermometer. So if you multiply 1 or zero point 0.5 or 2 degree with 0.01, this value is very small, right?
Yes, sir.
And that is very close to 0 degree Celsius, isn't it?
Yes, sir.
Hello?
Hello, sir.
Yeah, the actual uncertainty in theta is least near 0 degree Celsius. This one is the answer. C.
Yes, sir.
Is it clear?
No, sir.
You, huh?
Still confused, sir.
Is it clear?
No, sir. I'm still confused, sir.
Your actual uncertainty, we know, like you are getting 50 degrees Celsius here, temperature reading, right? So
Yes, sir.
actual uncertainty means which one? Plus minus 1 degree Celsius, right?
Yes, sir.
Isn't it?
Yes, sir.
So if you multiply 1 degree with 0.01, then it will come very small, right?
Yes, sir.
And that small value we can neglect it. It is negligible. It's very close to zero, right?
Yes, sir.
So we will choose C. Now you check with
Yes,
other options. The percentage uncertainty in theta is least near zero. No, if you take percentage uncertainty, you multiply with 100. That time it's becoming bigger, right?
yes, sir.
And percentage uncertainty in theta least near 100 degrees, it is also wrong. It will not be so large, right?
Yes, sir. Yes,
Then
sir.
the last one, the actual uncertainty in theta is least near 100. It is not possible. Actual uncertainty will never be 100 degrees Celsius. It's quite impossible, right?
Yes, sir.
So you understood why the answer is C.
Yes, sir.
So you can write it here in notes. In your notes, you write it that plus minus 1% is equal to 0.01, and if we multiply actual uncertainty with this 0.01, which is very small value.
Yes, sir.
Have you written?
Yes. Writing it, sir.
Yeah, write it. Otherwise, you cannot get it later. Have you completed? Are you done, Sufyan? What you wrote?
Yes, sir, I'm done.
What you wrote?
I wrote, yeah, I wrote plus minus contribution is equal to 0.01, and if we multiply it with 1, it becomes a very small number which is almost negligible, so it is near 0.
Okay, so you also write one another thing like typical thermometer reading. Yeah, you write another note that is typical thermometer reading. You write 50 plus 50 degrees Celsius plus minus 1 degree Celsius.
50 degree plus minus 1 degree Celsius.
Yeah, 1 degree Celsius. So here 1 degree Celsius is your actual answer. You label here 1 degree Celsius is actual uncertainty, and 50 degree is your measured value. Okay.
Yes, sir.
So now you are clear what is called actual uncertainty, right? So in your any measured value, the uncertainty you have, that is called actual uncertainty, right?
Yes,
In
sir.
in thermometer normally we have 1 degree Celsius, but you are taking the average, it comes 0.5. If your smallest value in the thermometer is 2 degrees Celsius, then your actual uncertainty will be 2 degrees Celsius. Is it clear? So
Yes, sir.
1 degree is coming from the scale, like in your ruler you can measure till 0.1 centimeter, right?
Yes, sir.
So 0.1 centimeter is your actual uncertainty. Like if you are measuring anything, the length of anything, it is coming 5 centimeter, then you write 5 plus minus 0.1 centimeter. Is it clear now?
Yes, sir. Yes, sir.
If you are taking average, then it will come 5 plus minus 0.05 centimeter. Is it clear now?
Yes, sir.
When you are taking the average, the actual uncertainty will be divided by 2 from the smallest value. Okay, so it's
Yes, sir.
clear now. Now we are going to question number 30. Okay,
Yes, sir.
question number 30, can you read it please?
Yes, sir. A digital meter has an accuracy of plus minus 1%. The meter is used to measure the current in an electric circuit. The reading on the meter varies between 3.04 ammeter and 3.08 ammeter. What is the value of the current with its uncertainty?
Okay, so this one is a very tricky question, difficult question, and it is one of the latest paper question, huh? And how to do it? They are saying what is the value of the current with its uncertainty. We have the values, the reading range, that is from 3.04 to 3.08, right?
Sir.
And the uncertainty given is 1%. So 1% means 0.01, right?
Yes, sir.
1% means 0.01 if you are taking in fractional uncertainty. So your reading you are getting 3.04. In that one we have this uncertainty. Again, the reading you are getting in 3.08, that one also has this uncertainty, right?
Yes, sir.
The plus minus 1%, they are saying accuracy. So
Yes,
your value varies from 3.04 to 3.08. If you multiply 3.04 with 0.01, what it comes? Check. You write
2.04 minus 6.
you write here minimum I. Minimum I. This way you write. Minimum I equals 3.04 minus 0.01 multiplied 3.04 equals, what is the reading coming? Check.
So why do we multiply 3.04 again?
Yeah, very good question. Look, we wrote here at the beginning one thing, that is minimum I, right?
Yes.
Minimum value of I. So when we are getting this one, we are getting the error in 3.04. What is the possible error in 3.04? That one we are getting, right? Isn't it?
Yes, sir.
And
Yes, sir.
if you are getting this one, this error, that one will be subtracted from 3.04. That means that could be our minimum value of I in emitter.
Yes, sir.
That's why we multiplied. So you write here, what is the answer coming? Check.
3.0096.
So we can write 3.01, right?
Yes, sir.
3.01 ampere. Now maximum value of I, what it comes? This is minimum
Mm,
I, this is
yes,
maximum
sir.
I.
This is 3.08 plus 1 multiplied by 3.08.
Yeah, 0.01 multiplied by 3.08. Yeah, so write it 3.08 plus 0.01 multiplied 3.08 equals, what it comes?
Yes, sir. I'll do it. It is 3.11.
3.11. Okay, so 3.11 we are getting amperes, right? Now we have here 3.04 in our measured value. In our measured value, we got 3.04 and 3.08. If you take the average, it comes 3.06, right?
Yes, sir.
That one we understand that every value we have 3.06, so it will come 3.06 if you take the average. Now, if you subtract the maximum of I minus maximum of minimum of I, then divided by You must give here bracket, otherwise calculation will come wrong. Divided by 2. What it comes? To get uncertainty, we have to subtract, right? These two values, maximum and minimum. That's coming 0.10, right?
Yes, sir.
Hello. As we are getting two
Hello, sir.
readings, like to get the uncertainty in these two values, we have to subtract, right? Their difference. So the difference is coming 0.10, right?
Yes, sir.
So if it is coming 0.10, then divided by 2, it comes 0.05. Is it clear?
Yes.
So
Yes,
what
sir.
should be our answer?
C.
C, right?
Yes, sir.
So clear, this one is clear.
Yes, sir.
So can you please take the snap of this also and send it to our group like before?
Yes, sir. I did it. I took the snap.
Yeah, you send it also in our group, please. Now with this question is done, our MCQ part is done, right?
Yes, sir.
And also our structured part almost done. That is question number 5 and 6 left, right?
Sir.
Question number 5 and 6. Let us go there. Huh? Question number 5 and 6. Or you will try at home.
Yes, sir. I think I will try it at home.
Yeah, because you have to try also, right? That how much you can do. Look,
Yes, sir.
question number, these two we did before, right? Okay, we have this
Yes,
one
sir.
also left. Question 31 is left. Okay, do 31. 32 we did, but 31
Yes,
is
sir.
left. Yeah, do it. 31. Can you read 31?
Yes, sir. Students take readings of the volume of a liquid using three different pieces of measuring equipment X, Y, and Z. The true value of the volume of the liquid is V. The student's results are shown. Yes, sir. How many pieces of equipment are precise and how many are accurate?
So precise and accurate. This idea already we discussed, and now you from the diagram you relate that idea. Which one is showing you precise and which one is showing you
Yes,
accurate? Look, in the graph we are having number of readings and the volume, right?
yes, sir.
So we are having number of readings and volume. The volume true value is marked in the graph, right?
Yes, sir.
And you see in our y, the value, the peak, we see very far, right, from the true value.
Yes, sir.
And number of readings uh, we are getting going sharp. Even this value is not giving us any neither precise nor accurate value, right?
Yes, sir.
In y, but in z we have number of readings. You see there is sharp, right? Sharp,
Yes, sir.
sharp edge. So we have here number of readings. Those are accurate, right? You see the true value,
Yes, sir.
isn't it? True value is exactly to the sharp edge, isn't it?
Yes, sir.
True value is labeled at V. So we can understand Z is giving us number of accurate that reading, right? So
Yes.
in your note you write that number of accurate pieces of equipment that is showing us in Z.
Yes, sir.
In Y we told it's neither precise nor accurate. And precise means we will get more readings, right? Closer to each other, isn't it?
Yes, sir. Yes, sir.
So we are having precise volumes which are closer to the true value, mostly in X, right?
Yes, sir.
So we can say for number of pieces of equipment precise, that is for X, right? So
Yes.
label there in your copy, you write there number of precise pieces of equipment is shown in X.
Yes, sir.
So what should be your answer?
A.
A. Very good. So by this one, we are done with this worksheet, right? Yes,
Yes,
we
sir.
are done with this worksheet except structured question 5 and 6, right? You can see we did all this, right? So 5 and 6 we are left. We'll try them, right? 5, 6, like if you again review all other questions, you can easily do 5 and 6. It's not that much difficult. Will you try them or you'll do now?
Sir, you show me five and I will do six, sir.
Mm-hmm.
Sir, you show me how to do five and I will do six, sir.
Okay, okay, no problem. So you read it, huh? 5.
Okay, sir. The microphone detects a musical note of frequency F. The microphone is connected to a cathode ray oscilloscope. The signal from microphone is observed on the CRO as illustrated in figure 5.1.
Yes. So you see the figure 5.1 is showing you 1 centimeter, right? 1 centimeter is 5 small square is showing, right?
Yes, sir.
Isn't it? So from here you can get the value like peak to peak. What is the reading? You can find it from here, right? So if you
Yes,
see
sir.
here, bottom part, the trough one, that one is more easier to get the peak to peak value, right?
Yes,
Isn't
sir.
it? So these
Yes,
two
sir.
things we found here, and now we will continue here. The time base, can you continue?
Yes,
Continue,
sir.
please.
The time-based setting of the CRO is 0.5 meters second per centimeter. Uh, the Y plate setting is 2.5 meter volt per centimeter.
Mm-hmm.
Use figure 5.1 to determine the amplitude of the signal.
Yes, so here you got uh, time-based setting. Time-based setting is shown in the x-axis, right? And
Yes, sir.
the y plate, that means the vertical one, y-axis is showing you the voltage, right? Millivolt per centimeter, isn't it?
Yes, sir.
So they are asking now to find the amplitude of the signal. We have here 2.5 millivolt per centimeter. We will check in the uh, diagram. Amplitude means the displacement from the rest position, right?
Yes, sir.
Isn't it?
Yes, sir.
From the rest position, how much it's going. So here is given 1 centimeter. So each of the small square is zero point 0.2 centimeter, right? Now from
Yes,
here,
sir.
if you check, if you go down, you will see how many small square is after this line. It is giving you 11, right? 11
Yes,
small square, right? Till here 10, isn't it?
yes,
If
sir.
this much is 1 centimeter, then from here to here it is 2 centimeter, right? This line, isn't it?
Yes, sir.
So if it is 10, then we have after 10 1 small square. It is 11, right? So 11
Yes, sir.
means 2.2. 2.2,
Yes,
right? Till here 2,
yes,
then zero point 0.2. 2.2 centimeter. So how we'll do it? Our Y plate setting is 2.5 millivolt per centimeter. Then 2.2 centimeter, how much it comes? Check. Then we write here 2.2 multiplied 2.2 centimeter, you write, multiplied 2.5 millivolt per centimeter, right? Isn't it?
yes, sir.
So centimeter will be cut. Then what is the value coming? Answer?
It comes. Let me see, sir.
Check how much it comes.
5.5 meter voltmeter, I guess.
5.5 millivolt,
Let me-
right? Because
Yes, sir.
centimeter already cut. Then we have 5.5
Yes,
millivolt. It's millivolt. Now the frequency. In your x-axis scale is given 0.50 millisecond per centimeter. That means you have to first find the time period, right? And you
yes, sir.
know one relationship with time period and frequency, right?
Yes, sir.
And that is f equals 1 by t or t equals 1 by f, whatever you say.
Yes,
So if you have the time period, you can find the frequency. Is it clear?
sir.
Now, you see, here we have the peak to peak distance, right? That is giving us time period.
Yes, sir.
So from this peak to this peak, how many small squares are there? We have to find. We can understand here we have till here we have 3 centimeter, right?
Yes, sir.
Till here, from here to here 3 centimeter. Then after that
It's
one,
small.
yeah, we have here another line. So if you go from here back, it's easier for us. So here 2 small square is, we can deduct, right, from here.
Yes.
So if we have from here to here uh, 4 centimeter, then point 2 if you deduct, it's coming 3.8, right?
Yes, sir.
3.8. So 3.8, how much it comes? Look here, 3.8 centimeter, right? Do you
Yes.
understand how it is 3.8? Hello?
Yes, sir. Yes, sir.
Yeah, 3.8. So 3.8 we'll write here for the time period. You write here time period T, capital T, equals, we got here 3.8 centimeter. You write here 3.8 centimeter, then you multiply. And what is your time base setting? 0.50, right?
Yes, sir.
0.50. It's written millisecond per centimeter, right? So
Yes,
per
sir.
centimeter and centimeter will cut. Then 3.8 multiplied by 0.50, it will come how much?
1.9, sir. 1.9 millisecond.
1.9 milliseconds. So we got here this one time period, right?
Yes, sir.
Now we have to find frequency. Frequency equals 1 by T. So what will be the frequency? 1 by 1.9 millisecond.
Yes, sir. The answer is 0.53.
0.53, but it was millisecond, not second. So
I say milliseconds, sir.
yeah. So millisecond, if you want to convert to now frequency, to convert to frequency, and the answer is given in hertz, right?
Yes, sir.
So hertz is SI unit. So before calculation, you convert millisecond to second.
Yes, sir.
Before converting, you before getting the frequency, you convert millisecond to second, then you calculate. If you
Yes, sir.
convert to second, it will come 1.9 into 10 to the power minus 3, right?
Yes, sir.
So the value you got, that one should be multiplied with 10 to the power 3, because when it comes upper side, 10 to the power minus 3 comes to 10 to the power plus 3, isn't it?
Yes, sir.
Milli will convert to kilo. So if you multiply with 1000, what it comes? Whatever the answer you got, if you multiply with 1000, you will get the answer.
Mm.
Check what is the answer coming.
1900.
19?
00.
No. I said 1
Multiplied by
by 1
1000.
point 1 by 1.9 multiply with 1000. That comes what?
Oh,
Because you have to divide, right? 1 by 1.9.
it is. It is 5.26 times 10 to the power minus 4.
Not minus 4. It should be, I said 1.19 multiply with 1000. Then it comes what? Check. When you are writing 1.9 into 10 to the power minus 3, you should give bracket. Otherwise, it will come wrong. It should be 526. Check.
Yes, sir. Now I got it.
Yeah, 526 hertz. So we don't have that much time to continue the rest part because that part is required more discussion, right? We need more time. So you try them, huh? Question number 5, rest part, and rest part means part A3 and then B left. You should try that part, okay?
Yes, sir.
And 6, this 2 part you will continue, okay? As homework,
Yes,
okay?
yes,
Now you tell me those questions you told me at the beginning, which we did in our 16th. MCQ, which MCQs we did? Can you tell me? MCQs 29, then after that what we did? 1, 6,
9.
9, 10, right?
Yes, sir.
Then structured question we did 7, right?
Yes, sir. Yes, sir.
Okay. Thank you. Thank you so much. Huh? Love this.
Thank you, sir. Thank you.